I think that the most important point I want to make is that, what I referred to earlier, that we've realized that the true problem, the true difficulty, and where the greatest potential is building the machine that makes the machine. In other words, building the factory. And really thinking of the factory like a product. Not sort of a hodgepodge of things that are bought, where the machines are kind of bought from a catalog. But actually, just like we do with the car, we're going to try to create a car by ordering a bunch of things off a catalog. We design the car the way it should be, and then we make, either we or with working with suppliers, make all of those individual components. And there's almost nothing in a Model S that's in any other car. And I think the same approach is the right approach to take when building the machine maker, the factory. I actually think that the potential for improvement in the machine that makes the machine is a factor of 10 greater than the potential on the car side. I think maybe more than a factor of 10. And I've really come to appreciate that, over the last 2-3 months in particular, when I've sort of just been on the production floor all the time and sort of seeing things, running production personally at a detail level. I don't even have a desk or an office anymore. I'm just basically standing on the production floor and occasionally meeting in a conference room. And it's like, wow. I do my favorite thing, which is apply physics first principles. It's like the best tool possible. And it's like, wow, when you think of a production facility on a fundamental level, for a given size of factory, the output is going to be volume times density times velocity. So then let's sort of look at our factory and say, okay, what is the density of useful to non-useful volume? It's crazy low. It's like 2 or 3%. If you look at volumetrically, not just on a planar level, but volumetrically, it's literally 2 or 3%. When you say car to non-car volumetric ratio, like, wow, okay, that seems like there's a lot of room for improvement. And then you say, like, velocity. What is a reasonable expectation for the exit velocity of vehicles from the factory? And at first you may think that, say, some of these advanced car factories around the world are very good at making cars, and they may make a car every 25 seconds. And that sounds fast, but actually, if you say, well, the length of the car plus some buffer space is approximately 5 meters, and so it's taking 25 seconds to move 5 meters. Okay, that's 0.2 meters per second. Basically, you're not much faster than a tortoise at that point. And so it's like, wow, that really doesn't seem fast. Like, how come these factories, like a sort of slow walk would be approximately, or slow to medium walk would be 1 meter per second. And a fast walk would be 1.5 meters per second. And the best car factories in the world are doing 0.2. Like, seems like you should be able to have cars exit at least walking speed. This doesn't seem so crazy. And then the density improvement, like, there may be as much as an order of magnitude improvement in density possible as well, going from maybe 2 or 3% to 20 or 30% of the volumetric density being optimal. And like, you can also think of it like the design of a modern system on a chip or a computer. And you say, if you look at, say, the complexity of the board, and you see how how close together the line traces are, and how focused things are on clock speed and data transfer from RAM to say a solid-state disk or an internal CPU cache. It's like, wow, there's crazy potential for improvement here. I think at least an order of magnitude potential for improvement on production. And so with less, like significantly less engineering effort, we can make dramatic improvements to the machine that makes the machine. I think I think like probably a lot of people will not believe us about this, but I'm absolutely confident that this can be accomplished.
Yeah, there are opportunities we're finding all over the place, and as you start to shift some of the design resources that have been improving motor technology and power electronics or batteries, and are working so hard to try and find tenths of a % of efficiency gain or performance gain on those different systems. And when they start to go and look at the factory, they say, "Oh my gosh, this is crazy." We can find, as you were saying, easily tens of % or 20, in some cases hundreds of % efficiency gain that were sort of unheard of in terms of what you could do in the design world. So the impact there is pretty phenomenal and quite close at hand.
Yeah, so we're basically going to design a factory like you design an advanced computer, and in fact, I think use engineers that are used to doing that and have them work on this. And I found that like once you sort of explain this to a first-rate engineer, the light bulb goes on. They're like, wow. As JB was saying, like they spend huge amounts of effort trying to get a fraction of a % of improvement on the product itself. But actually, that same amount of effort will yield an order of magnitude greater result if you focus on building the machine that builds the machine. And it's just that a lot of engineers don't realize that this is possible. They think that there's like a wall. They're basically operating according to these invisible walls. So we just need to, we're in the process of just going through and explaining those walls don't exist. And I think it's going to be pretty amazing. Yeah.